welcome to the deep dive. Today we're tackling Retrieval Augmented Generation, RAG for short.
Right.
The idea, basically, is how we can make smart AI even smarter by feeding it specific, up-to-date info it wasn't trained on.
Exactly. Think of it like giving an AI researcher access to a specific library right when they need it.
So our mission here is to unpack what RAG is, why it's important, and, the basics of how it works without getting lost in the weeds.
Let's do it. It's a really powerful technique.
Okay, so first things first. What exactly is RAG, and why should we care about it right now?
Well, fundamentally, RGAG is a method to supplement a large language model's internal knowledge with external data.
Supplementing. Okay.
Yeah, because these models, they know a lot, but their knowledge is frozen at the time they were trained. It has a cutoff date.
Right. So they don't know about events or information after that date.
Precisely. Or, maybe more importantly, they don't know about your specific private data, like internal company documents or recent reports. RA lets the AI pull in relevant pieces of this external information when it's generating a response to a query.
So it makes the answers current or specific to data it wasn't trained on.
Exactly. That's why it matters. It makes AI vastly more useful for tasks needing, real-time info or knowledge about very specific domains. Think customer support using the latest manuals or a research tool accessing recent papers.
Okay, that makes sense.
Yeah.
So how do you actually build one of these RAG applications? What are the main stages involved?
Broadly speaking, there are two key phases. First, you've got the indexing part.
Indexing.
Yeah, this is mostly done offline. It's all about preparing your external data source, that library we mentioned.
Preparing the library. Got it. And the second phase.
That's the retrieval and generation phase. This happens in real time whenever a user asks a question.
Okay, indexing first, then retrieval and generation. Let's
Yeah.
break down the indexing. What does preparing the data actually involve?
It usually involves 3 steps: loading, splitting, and storing.
Loading, splitting, storing. Okay. Loading from where?
From wherever your knowledge lives. It could be web pages, documents, databases. LangChain, for example, has things called document loaders. Like web-based loaders specifically grabs content from URLs.
So you point it at a web page and it pulls the text.
Pretty much. It often uses tools like Erlib and Beautiful Soup underneath to fetch and parse the HTML. You can even customize what parts of the HTML it grabs, focusing on just the main content, for instance.
Right. Ignore the ads and menus and stuff. Okay, so that's loading. Then splitting. Why split the documents up? Why not just use the whole thing?
That's a really key point. LLMs have what's called a context window.
The limit on how much text they can process at once.
Exactly. If you feed it a massive document, it might lose track or just not be able to process it all effectively. Plus, searching for specific info is way more efficient in smaller chunks.
Like finding a needle in a smaller haystack.
Precisely. So you use text splitters, like LangChain's recursive character text splitter. It tries to break the text along natural boundaries, paragraphs, sentences, lines, until the chunks are below a certain size.
And I saw something about character overlap.
Yeah, that's important too. You often have a small overlap, say 200 characters, between consecutive chunks.
Why?
It helps maintain context, so a sentence or idea that gets split right at the boundary isn't completely lost between chunks. The next chunk still has a bit of the previous one's end.
Clever. Okay, loaded, split, now storing. How are these chunks stored?
This is where embeddings come in. Each chunk is passed through an embedding model, like one from OpenAI.
Embeddings.
Yeah.
Turning text into numbers, right? Vectors.
You got it. These vectors capture the semantic meaning of the text chunk. Chunks with similar meanings will have similar vectors in this high-dimensional space.
Okay, so numbers representing meaning, then where do they go?
They get stored in a specialized database called a vector store. Chroma is a popular example.
Vector store, like Chroma.
Yep. And these vector stores are optimized for finding vectors, and therefore text chunks that are closest or most similar to a given query vector, often using something called cosine similarity.
So you can quickly find the chunks that mean something similar to your question.
That's the core idea of the storage and retrieval part.
All right, so that whole process, loading, splitting, embedding, storing in a vector store.
Yeah.
That's the indexing phase, the offline prep work.
Correct. Building the searchable knowledge library.
Now, what happens at runtime when I actually ask a question That's the retrieval and generation part.
Exactly. So you type in your question. The first step is retrieval.
Getting the relevant info back.
Right. Your question is also converted into an embedding using the same model we used for the chunks. Then a component called a retriever langchain has vector store retriever takes that query embedding and uses it to search the vector store. It finds the top n chunks whose embeddings are most similar to your question's embedding.
So it pulls out the most relevant few pieces of text from that library we built.
Precisely. And it's crucial to sometimes, check what documents actually got retrieved just to make sure the system is finding genuinely relevant stuff.
A good point.
Huh.
Okay, so it retrieves the best chunks. Then what?
Then comes the generation step. Those retrieved chunks of text, along with your original question, are packaged together,
Packaged how?
usually formatted into a prompt. This prompt basically instructs the LLM, say, GPT 3.5 Turbo or GPT-4. Here's the user's question, and here is some potentially relevant context I found. Please answer the question using this context.
So you're explicitly telling the AI what information to use.
Exactly, and that's the magic. The LLM doesn't just rely on its old training data. It uses the specific, relevant, potentially very current information from those retrieved chunks to formulate its answer.
Making the answer much more grounded and accurate.
Way more grounded, accurate, and specific than it could be otherwise. LangChain uses something called the runnable protocol, which makes it easier to chain these steps, retrieve, format prompt, generate together smoothly.
Interesting. And you mentioned LangChain allows customization here. It's not just one fixed way to do this.
Oh, absolutely. That's one of his strengths.
Mhm.
The runnable protocol lets you swap components in and out. You can use different loaders, different splitters, different embedding models, different vector stores,
All right.
different retrievers, even completely custom logic for how you construct the final prompt that goes to the LLM. You can really tailor the whole pipeline to fit your specific data and the kind of answers you need.
So you have a lot of control over how it finds and uses the information.
A huge amount of control. It's not just a black box.
Okay, this is really clarifying.
Yeah.
So just to kind of wrap it up, our reg is essentially this clever approach to give an AI like a targeted searchable library to consult before it answers.
Yep. Overcoming that static knowledge problem.
And we saw there's a preparation phase, indexing, loading the data, splitting it smartly, and storing it as embeddings in a vector store.
The offline library building.
And then the runtime phase retrieval and generation, where a question fetches the most relevant chunks, and the AI uses those chunks to generate a much more informed answer.
That's the core loop. Retrieve, then generate.
It definitely opens up a lot of possibilities for working with specific or rapidly changing information. It makes you think, what kinds of specific knowledge bases or real-time data feeds out there would be most transformed if you plug them into a RAG system? Something to ponder.
Definitely. The applications are really just starting to be explored.